Okay, these are the last free response questions right here. It says 4 examples with the answers listed at the bottom right here, and I'll go through and do the work really slowly for the first couple, and then I'll try to speed through the last couple because they'll all be the same pattern anyway of stoichiometry steps. So this one says 25 milliliters of barium chloride is titrated with silver nitrate solution. 18.55 milliliters of the nitrate solution is required to completely precipitate the chloride ion and the silver chloride. What is the molarity of the barium chloride solution? So step number 1 is to write the balanced chemical equation. So barium chloride is titrated with silver nitrate. Swap the cations. The barium is going to go together with the nitrate. Don't forget that barium is +2 and nitrate's -1. And the silver chloride is going to be my solid precipitate. I'll need a 2 right here to balance the equation to go along with a 2 right here. Second, convert to moles. So it gives me 25 milliliters is titrated with the 0.15 molar silver nitrate, and it tells me that 18.5 milliliters of the silver nitrate solution is required. So if you look closely, they tell you 2 things about the silver nitrate, and those 2 things can help you find moles. So the molarity triangle tells you that if you know the molarity and if you know the volume in liters, you can find moles. And so I could find the silver nitrate solution right here. So moles equals molarity times liters. And so my molarity of my silver nitrate solution is 0.150 moles per liter, because remember capital M is the same as moles per liter, times my liters, and be careful to convert this 3 to the left, so 0.01855 liters, because it was 18.55, so 1, 2, 3 to the left. The liters cancel with the liters. Now we go ahead and do this in our calculator. 0.15 times my 0.01855. Let me just double check, make sure I got the right numbers in the calculator. And I end up with 0.0027825 moles of my silver nitrate solution. Okay? So now that I've done step number 2 and converted to the moles of the thing that I can, and I know that I don't have amounts of both, so I'm going to skip step 2.5. I go to the mole to mole ratio. So rewriting over here, 0.0027825 moles of the silver nitrate. Multiply sign, put a line, put the silver nitrate in a position where it's going to cancel, and there's a 2 in front of that. And then the thing that I want to know is what is the molarity of the barium chloride solution. So I want to know this. So I'll put barium chloride up here as my new desired set of units, and there's a 1 in front of that. So I'll take this number and divide it by 2, and I know that I will need 0.00139.125 moles of the barium chloride to precipitate all of my silver nitrates right here. That's what this mole to mole ratio allowed me to do. And so lastly then I convert to the asked for units, and my asked for units is to what is the molarity, or find the molarity. And the molarity is equal to moles divided by liters. So here's my moles, 0.00139.125 divided by the liters, which the liters of course is given to us in the question. There's 25 milliliters of that. And be careful, make sure to put it in liters, so 0.025 liters. 25 can be converted to liters by going 3 to the left, so 0.0125. And so take my 0.001395 divided by 0.025, enter, and the molarity is 0.05565. Looking at my significant figures, I have 4 sig figs here, 4 sig fig here, and I end up with 4 sig figs in my answer. Put the capital M at the end, circle, square, star, and box my answer, and I now know the molarity of that barium chloride. Okay, so look back at the steps. Balanced chemical equation, converted to moles using the molarity triangle, did the mole-to-mole ratio to determine the moles of the substance that I was interested in, and it asked about barium chloride, so I knew that. And then lastly, convert to the asked for units. And what did they want to know? They wanted to know molarity, so I took the moles that I found, divided by the liters they told me in the problem. All right, let's look at the next one in a little more detail. Phosphoric acid solution is required. Solution required 27 milliliters of a 0.15 potassium hydroxide solution to neutralize. What is the molarity of the acid? So step number 1, balance chemical equation. So phosphoric acid is H3PO4. Potassium hydroxide is KOH. Swap the cations and I get some water, and I'll also get K3PO4 as my other product because potassium is +1 and phosphate's -3. So balancing this equation, I believe I'm going to end up with a 3 right here. So that gives me 3 hydroxides. 3 hydroxides I'm going to need, and I'm going to need 3 hydrogens right here, so I'll put a 3 in front of there. And I have 1 phosphate and 1 phosphate, 3 potassiums, 3 potassiums. So step number 1 is done. Step number 2, convert to moles. And so I'm given a volume and a molarity. If I get a volume and a molarity, I can find moles. And so my moles are equal to my molarity times my liters. And my molarity is 0.155 molar times my liters. Careful, 3 to the left, 1, 2, 3, 0.02755 liters of my potassium hydroxide solution. Multiply those two together on my calculator. So 0.155 divided by 0.02755. Enter. That means 5.626 moles of the potassium hydroxide are needed. Let me just double check my math here. 0.155, 0.02755. Those are my milliliters and my molarity of my potassium hydroxide solution. Okay? That's step number 2 done. Step number 3 now is the mole-to-mole ratio. So start with my 5.626. Oh, I think I did divided by on here. Yeah, that looked really funny. Whoa, back up just a second. I need to multiply these two numbers. And notice I put divided by on my calculator right there. I did not mean to do that. Let me fix that quickly. 0.155 times 0.02755. Yeah, that answer didn't make any sense. This should be 0.00427.025 moles of potassium hydroxide. That's how much it needs. Much better now that I got the multiply sign in there. So don't write that 5 in there. Rewrite this number now. 0.00427.025 moles of potassium hydroxide. Put a multiply sign, put a line, put potassium hydroxide in a position where it's going to cancel because now I'm doing my mole-to-mole ratio with the substance that I desire to know, and I desire to know phosphoric acid. So H3PO4 on the top. There's a 1 in front of the H3PO4. There's a 3 in front of the KOH. And so I'm going to take my 0.00427 and divide that by 3. And I end up with 0.00142341 and a few more decimals. Carry all those decimals through. We'll round to the right number of sig figs at the end. And now my next step is to convert to the asked for units. And what do they want to know? They want to know the molarity of the acid. And so molarity is equal to moles divided by liters. So molarity is equal to these number of moles right here divided by the liters of the phosphoric acid solution, and there's 25 milliliters of that because this is my moles of H3PO4. So I'll put my moles of the H3PO4 right here, and my liters on the bottom, which would be 0.025 liters. It's 25 milliliters, so 1, 2, 3 to the left. So let's do this on calculator. You guys can watch, make sure that I hit the divided by button this time. And then 0.025, enter. And so my molarity would be 0.0569366 repeating. And I need a total of 4 sig figs here, 4 sig figs here, 3 sig figs right there in that number. So I'll want to end up with 3 sig figs in my answer, which now that I look up here, I should have probably had 3 sig figs in this answer. So this one should have been rounded to a 7 right here. Anyway, back to finishing this one. This should be rounded to 3 sig figs, so 0.056. Now I look to the next number after the third sig fig. If it's 5 or more round up, it's not, so I'll just leave a 9 right here, and that would be a capital M for molarity for my H3PO4. Okay, come back with the next 2 in the next video.